Assalamu alaikum guys, welcome back to another lecture of DSP Digital Signal and Processing. This is the 7th lecture. My name is Khurram Aziz and my roll number is 16TE59. Now in this lecture we will study the transformation of signals. We have different methods for the transformation of signals. Some of them are listed here. First of all, we have the direct method. The second one is shifted scaling, impulse response. The third one is convolution sum, and the fourth one is Vozney algorithm. So the transformation is basically a process, is a technique which we use to change and process a signal. So the method that we are going to discuss in this lecture is the direct method, which is, let me go through some quick points here, which is valid for only linear time invariant system, meaning the system that are invariant to time, which does not depend upon time. And the other systems for which the direct method can be opted are finite systems, which provide a finite response. Now we will discuss an example. This example includes uh, a system which is defined as below: y of n is equal to x of n minus 2x of n minus 1 plus 3x of n minus 2. Here we have defined our set of x. This is our x. This is the 0th position. It is an impulse or unit impulse on the 0th position, and this is this first, and this is the second position. Now when we input -1, we will have x of -1. We will have here x of -1, which is not defined. This position was not defined, which will be equal to 0. Then we will have x of -2, which is also not defined, and it will also be equal to 0. And the third one is x of -3, which is also equal to 0. The first one we will have is 0 for y of -1. Then we will put 0, x of 0. We will have x of 0. Here we have 1 at the 0th position. The other one are obsolete, so here we have 1. For y of 1 we have x of 1 minus 2 x of 0. For the 0th position we have a 1, so it will turn out something like this: 1 minus minus 2. Here we have a minus 1. For 2 we have 2 if you do the maths, and for 3 we have 1. For 4 we have 3, and for 5 we have 0. So the resultant response will be 0, 1, -1, and 2, 1, 3, and 0. And this is for the 0th position. Okay, now when we will see the impulse response of this particular system, we will have to replace the unit impulse with x of n, and we know that unit impulse is 1 on the 0th position in the time scaling axis. Here we have a 1 at 0, so we will replace it with x of 0 will be equal to 1. This is the only definition of our system. The y of n, will be replaced by the impulse response of the system. For h of 0 we will have, for h of -1 we will have 0. For h of 0 we will have 1. For h of 1 we will have -2. For h of 2 we will have 3. So the resultant will be h of n will be equal to 0, 1, -2, and 3. So this will be our resultant vector. That's all for this lecture. Thank you for tuning in, and we'll see you next time.